All right, in one of the Batman movies, Batman does a falling push-up, and it was pretty neat, and a lot of people think it's really neat. So today we're going to do the math behind it and say how much you need to bench press in order to actually do this move. And it'll be a function of like your height and your weight and a couple other things, but mainly those two things. So I'm going to show a couple clips of it just so we get an understanding of, what the move is. So this is it from the actual movie.
Oh, drive sports cars, date movie stars, buy things that are not for sale. Who knows?
And this is someone actually doing it. If you don't do it right, well, if you don't know that you can do it beforehand, you could like smash your chin, which is not good. So we're actually going to do the math. So the idea, well, okay, first of all these numbers are based on my body. So I weigh 160 pounds, which is 172 kilograms. I'm 5'10", which is 1.778 meters. And I looked this up, and I also did some experimenting on my own, and this seemed like a good assumption. So I assumed that the center of gravity of height of my body was 55% of my overall body height, which in this case, 55% of 1.778 is 0.98 meters. And then I also assumed that my arms, I actually measured my arms and I got 20 inches, and then I just did, and 20 inches is 51 or 0.51 meters. So I did 0.51 over 1.778, and I got about 28%. So I assumed that your arms are about 28% of your overall height. And then I assumed that your final height is 0. So what exactly is going on? So I broke it up into 3 parts. So the first part, you're just standing up. All of your weight is at your center of gravity height in the middle of your body, almost middle of your body. Then you fall down and you fall down to a point that is a height of your arms away from the ground. And then your arms decelerate you from whatever speed you're at down to 0. Down to 0 at a height of, I assume 0. If you actually assume 0, you'll probably smash your chin. So you might want to change this to like 2 or 3 inches. But yeah, I assumed your final height is 0. So you go all the way down from 0.51 meters down to 0 meters. Okay, so what's the math? So between state 1 and state 2, you have mgh equals 1/2 mv squared. So the masses cancel out. Then you have velocity equals root 2gh, which equals root 2 times 9.81 meters per second squared times height. And the height would be 0.98 minus 0.51. Because I'm solving for the velocity right here. I'm going to erase that because it looks sus. 0.98 meters minus 0.51 meters. And this got me, let me see, a velocity of 3.07 meters per second. Cool, so that's saying at state 2, as soon as your arms hit the ground, and also if you actually measure your body, make sure not to include your hand length into that. Like, make your hand 90 degrees to your arm and just measure to like the palm of your wrists, because that's actually yeah, you're not going to catch yourself with your fingers. You're going to catch yourself with your palm. But yeah, this is the velocity as soon as your palms touch the ground. So then you have from there all the way until a height of 0 to decelerate yourself. So how do you do that? So from state 2 to state 3, the equation is v squared, this is just one of the kinematic equations, equals 2ax. It's technically delta x and a delta v squared. So what numbers do we plug in? We plug in our 3.07 meters per second minus 0, because our final speed is 0. We want to catch ourselves. Squared equals 2a. Our x would be 0.51 meters minus our final height of 0. Cool. So then we solve for a, and we get our acceleration as 9.46. 9.46 meters per second squared. Cool. And this is the deceleration rate that your arms have to push from the point that you touch the ground all the way until your arms are like at your side, basically. Cool. So that's an acceleration. How do we calculate the force? So force equals mass times acceleration. And the mass is the mass of your whole body, which for me was 72.6. Meters per second squared. I got a force of 687 newtons. No one cares about newtons. So in pounds, I think you multiply it by 0.224 and you get 154 pounds. So you have to bench press 154 pounds in order to do a falling, well, I have to bench press 154 pounds in order to do a falling push-up and not break my chin. Cool. Well, that doesn't really help probably most of you, because most of you probably aren't 160 pounds and 5'10". So what if you're a different height and a different weight? Well, all right, before I show that, well, okay, I made a plot, but on the plot, I kept my assumptions that the center of gravity height is 55% of your overall height, and your arms are 28% of your overall height, and your final height is 0. And all three of those things, especially this last one, will probably change for you. But they're decent assumptions, so I just went with them. So I made a plot, and I ranged the height. I'm gonna change colors. I ranged the height from 4.5 feet to 6.5 feet. So I'm right about there, 5'10". And the weight, so the person's weight, I ranged from 90 pounds to 250 pounds. So I would be between 150 and 170, which are the purple and green lines. So I would be somewhere between there. And that seems, what is that, like 150? Maybe a bit more than 150. What was my number? 154. Okay, perfect. Yeah, so this is a good plot. The numbers make sense. So the first thing that you notice is all of these are flat. All of them are flat lines, which is very interesting. And I didn't understand why initially, but then I thought about it some more, and I was like, all right, maybe it could make sense. So as your height increases, I have your arm length increasing at the same rate. It's not like a squared rate, or it's not like a 1 over something rate. They're both multiplied by a constant number. So that if your height increases, your arm length increases at the same like scaled rate, which means this whole term will increase, which means this whole term will decrease. But also this whole term will increase, I think. No, it actually won't. Well, maybe, I don't know. I don't really fully understand it, but I triple check the math, maybe even quadruple check the math. And this is it. It is a flat line. So the idea is, if you are 4.5 feet tall and you weigh, what would that be, 90 pounds? You'd have to bench press the same as someone who's 6.5 feet tall and 90 pounds. Chances are, if someone's 6.5 feet tall and 90 pounds, something's wrong with their health. There's no way they could be like that. But that's the idea. So as a more realistic example, if you're 5 feet and let's say 160 pounds, well, no, that wouldn't be 160 pounds. You'd have to use this, let's say 170 pounds. So you're on the green line. Versus if you're 6 feet, right here on the green line also, you have to bench the same amount. So your height doesn't matter. The only thing that matters here is your body weight. That's it. So based on your body weight, you can directly find how much you need to bench. But yeah, it's pretty freaking neat. Now you know how much you need to bench in order to do this move without smashing your jaw. But as I mentioned before, redo the calcs with your weight and all that stuff to get like a more exact number. And also, hello pen, I have it in eraser mode. Change that height number from 0. Make it like 3 inches to be safe or something. But yeah, that's literally it. It's pretty neat.